Hello students, today's agenda is to get a list for the emergency list. We're also going to be learning or reviewing about exponents, and you will be able to work on 1.1. Today students will be able to apply the rules of exponents, and again this is just a review because you already learned it in quarter 3 of math 1. So just to recall, and I think what I'm going to do is give you the examples and then give you the rule, okay? But if we have x to the third times x to the fifth, if they ask you to do it in expanded form, then that means x times 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 x. And looking at all of that, it looks like it's a multiplication of x times itself 8 times, so we can simplify it as x to the 8th power, right? Because you're multiplying x 8 times. So instead of doing all this work, mathematicians notice that when you're multiplying the same base to some exponent, all you have to do is keep the base that is common and add the exponent. So 3 plus 5 equals 8. So in multiplication, we keep the base, add the exponent. Okay, and so let me give you some other examples. If we have x to the second power times x, if we don't have a power, we say that in there we have el chiquitito. What does that mean? That we have a 1 in there. It's so tiny that you cannot see it. Okay, so we're adding that 1 to the other exponent. So again, keep the base, add the exponents. 2 plus 1 is 3. Okay, let's do some more because sometimes we don't have all the same bases. So let's say that we have 2 to the third times 3 to the second power times 2 to the 6th power times 3. Notice that in here we don't have all the same bases. So, and we also have a chiquitito. Okay, so we notice that these are the same base. So we're gonna write it once, write the base, keep the base for those two, add the exponents for the number 2, the base 2. So 3 plus 6 is 9 times, then we're going to get the other base that is different and keep that base, but add the exponents for that. So 2 plus 1 is 3. Okay, and that's how we're gonna leave it. Now let's do some that is different. So if we have x to the 7th divided by, remember that whenever you have a fraction or this line in here, it stands for division. Okay, again, this we're skipping because we have learned that that's the rule. Okay, in multiplication the rule is keep the base, add the exponents. This is just the reason, so you understand it. For division, again, this is the reason what I'm going to put in here. You can skip that once you learn the rule, but in expanded form is x times x times x times x times x times x times x, and that's divided by x times x times x times x, and any number divided by itself becomes 1. So x divided by x is 1, x divided by x is 1, x divided by x is 1, and x divided by x is 1. So all we end up with is x, and how many times does it multiply times itself? 3 times. So guess what? We have a 7, we have a 4 in the denominator, and the answer is x to the third. So 7 minus 4 is 3. So in division, we keep the base. Let me just simplify. Keep the base, subtract exponents. Okay, so that's the rule. Let's do some more. Okay, the next one, and it's gonna bring another rule. Well, let me do one like this first. So we keep the base, subtract exponent. 6 minus 3 is 3, but just like that. What if I have x to the third over x to the sixth? We keep the base. 3 minus 6 is -3. Okay, we put this one first. 3 minus 6, that's because what we're subtracting is bigger, so it's going to be -3. Okay, so that's why it's going to be x to the -3. And I don't know if you remember from the previous year that whenever we have a negative exponent, we send it to the denominator, and that makes it positive. Okay, when we have a negative exponent, we send the whole power to denominator to make the exponent positive. And it's when we get an answer from something, or even if they just gave you simplify this, then you have to do that, okay? Make it into a positive exponent. And so the answer will be 1 over x to the +3. Now let me show you in pink why that is so. So in expanded form, it will be x times x times x over x times x times x times x times x times one more. X divided by x is 1, x divided by x is 1, x divided by x is 1, and so I put 1 in the numerator. And what do I have in the denominator? I have x to the 1, 2, 3 to the third power. So that will be the reason why whenever we have a negative exponent is sent to the denominator, because when it comes from a division, well, you can see that a negative denominator, a negative exponent means the product happening in the denominator. Okay? So I hope that makes sense. Again, if the numerator is bigger, you're going to end up with a positive exponent. But if the numerator is, both are positive and the numerator is smaller, then you're going to end up with a negative, which means send it to the dungeon. Okay, the dungeon is at the bottom of the castle. Okay, send it to the denominator to make it positive. Al calabozo. Okay, let me see. Sometimes you're going to have the same base. So let's see, we have 3 to the third, 3 to the -2, or negative second power. So this is something that might get confusing, so I recommend that you write down what you're doing. So you're going to keep the base, but then you're going to subtract the exponents. So it's going to be 3 minus, because it says subtract, and then the exponent in the denominator is -2. So be careful. Don't forget, Some people forget that because there is a negative, they just put it once and that's it. But no, it's subtract. That means that you put an extra minus in here between these two. Okay, so 3 minus negative 2. And then remember that negative times negative is positive, or the big plus. Okay, and so 3 plus 2 is 5. Okay, that was a little confusing. I think I'm going to explain it again just to make sure that, okay, again is 3 minus negative 2. Some people prefer to see it in here like that. Negative times negative is positive, or the big plus. And now we don't have any negatives in the middle. So 3 plus 2, 5. Okay, and so that will be the answer. Some people say, teacher, can we just say that we keep this, the first one is the same, and then you just change the sign of the second one? That's also possible. So let's do it one more. So 3, and then change the sign of the bottom exponent. So it will be plus 2, which is 3 plus 2 is 5. So it all depends on how you see it, okay? It's the same thing, whichever helps you the most. Okay, let's go to the next one. So x to the negative third over x to the third power. We keep the base because it's the same base. And I'm just going to put this to divide it. So let me do the work here. It's going to be keep the same for the first one, and then just change the sign for the second one. So it's negative 3 minus 3 is equals to negative 6. Why? Because same sign, we add and keep the sign of the bigger one, but they are both the same, so either one is negative. We cannot have a negative exponent, so we're going to send it to the dungeon, al calabozo. It's going to be 1 over x to the 6th power. The next one is, okay, there it is. 2 to the negative 1 over 2 to the negative 4th. These are a little more confusing, right? Okay, so it's going to be, keep the base, negative 1 minus negative 4. So minus negative 4, or just change the sign of the other one. Remember, that's another way of seeing it. So negative 1, if it's negative 4, then it's going to be plus 4. Okay, in this case, it will be negative times negative is positive, or the big plus. 2 negatives together right next to each other make the big plus. Now, careful here. If you have a negative, you owe 1, but then you have 4, then you pay that one that you owe and you end up with 3. Or same sign you add, but different sign, you subtract and leave the sign of the bigger one. Okay, different sign, you subtract and leave the sign of the greater one. So 4 minus 1 is 3, and the greater one is positive, so positive. Okay, so this will be the answer. I'm just circling this or enclosing them so that we don't get confused with the rest of the example. Okay, the next one is x to the negative second over x to the second power. Keep the base. So the first one is negative 2 minus 2, or just change the sign of the second one. And again, 2 negatives you add and keep the sign of the greater one. Since both are the same, you keep the sign of any of the two. It's negative 4. We cannot have a negative exponent, so al calabozo, to the dungeon. Okay, and by sending it to the denominator, that becomes positive. Notice I'm going a little bit faster. Okay, now let's change it to something different. What if we have a parenthesis with a power and then another power outside? That's called power raised to another power. Okay, power raised to another power. In this case, we multiply. Oh, I shouldn't have told you that before. Okay, before we do that, and actually you already know because we saw this previously. So this means that we're multiplying this base or this power 3 times. So it's going to be x to the second times x to the second times x to the second. And we already learned up here that when we're multiplying, we keep the base and we add the exponents. So it's going to be 2 plus 2 plus 2 is 6, and that's it. So if we don't want to do all of this work, because sometimes it's going to be even bigger, all we need to do is basically multiply. So we keep the same base, x, and then multiply 2 times 3, 6. Okay, so anytime you have parentheses, you have exponents inside and then up there, outside, right next to each other, or even with other variables, then you multiply the exponent. The exponents. Okay. Sometimes, following that same rule, you will have, well, let me give you this example, x to the second to the negative second. So we multiply, so keep the base, multiply the exponents. 2 times negative 2, well, positive times negative is negative. 2 times 2 is 4. We cannot have negative exponents, so we're going to send it to the denominator, al calabozo. And that makes it positive. Okay, so that will be my answer. Okay, one more that you have to remember, or we're going to be using, and it's going to come up in some of the lessons, is anything to the power of 0. Well, anything to the power of 0, the answer will be 1. For example, if we have 3x, y, z, everything to the power of 0, the answer will be 1. The only instance when it's going to be a little bit different is when you have 3x to the 0. The 0 belongs only to that one variable. And so the 3, you're going to keep it. That becomes 1, because anything to the power of 0 is 1, and then 3 times 1 equals 3. Okay, so be careful whenever you have power 0. But yeah, that 0 belongs only to the base that it's with. If it has parentheses, then yeah, it belongs to the whole thing in the parentheses, but if not, then it's only to that base. And last but not least, anything to the power of 1 will give me that same base. Okay, it's like if there is nothing in there. And we saw it a little bit in the other ones where we didn't have anything. We have the chiquitito. Okay, so that's it for the powers. Now let's do some square roots. So the square roots, if there is nothing in here, that means that it's a 2. Okay, in there it's an imaginary 2. And what it means is that we're looking for a number that multiplies times itself 2 times, gives me the product of the number inside of the square root, which is 121. So what number multiplied times itself twice is equals to 121? Well, that will be 11, because 11 times 11 is 121. I told students that they can do prime factorization, and here it's, 11, it's going to be hard unless you know it. 11 times 11 is 121. This tells me that I need to do groups of 2, and so I need to put it only once. I said I'll send the captain in there. So let me do one more. If we have 81, you might say, oh, this is 3 times 27, 3 times 9, 3 times 3. And I know that some of you already said, wait a minute, that's 9 times 9. So the answer is, send the captain only, 9. But for those people who don't know, you can do all prime factorization and say, okay, there is an imaginary 2. I need to make groups of 2 inside. 2 inside. Okay? And so, from each group, I'll send the captain. So it's 3. And then from this group, I'll send the captain times 3. And 3 times 3, 9. Okay? I think it's going to be a little bit more clear once we do the ones that have different groupings. So for the next one, I'm going to ask you to do the cubic root of 8. Again, I'm going to do prime factorization, so it's going to be 2 times 4, and then 4 is 2 times 2. But then it says there is no imaginary number. It's actually there. It tells me that I need to put 3 in each group. And so I'm going to include. Now, careful. People say, why don't we include the 4 or the 8? Because the 4 is still being factored. But the 2 and the 2 and the 2 are all the way to the end. And those are the ones that we're going to get. Okay? So make groups of 3. And just send the captain from each group. So the answer is 2. So what does this mean? It means what number multiplied these many times. So it might say a 2, a 3, a 4, a 5. So that many times, these many times, times itself, equal the number inside. The number inside of the root. So the number inside is right there, okay? This number that is here. So this just tells me how many times I need to multiply the number times itself. And the answer will be this. Let's see, how is another way to say it? It's like the answer, this becomes the exponent, and this becomes the answer, the answer becomes the base. The index in the root becomes the exponent. And the number inside of the square root becomes the answer of 2 times 2 times 2. Okay, because 2 times 2, 4 times 2 is 8. Okay, hopefully that made it a little bit more clear. Okay, so now we're going to be looking for a number that multiplied times itself 4 times gives me 16. Again, you can just, some people will already know the answer because these are very simple, but if you're not sure, you can just start prime factorization. So it's 4 times 4 2 times 2, 2 times 2. Then it says make groups of 4 inside. Some people get confused and they think that this is the number of groups. And no, I said, no, it's how many inside of the cage. How many are there inside of the cage? 1, 2, 3, 4. That's how many we need inside of the cage. That many. And we only send the captain. So this, we don't put them in there. It's just going to be the captain representing. So again, what this means is 2 to the 4th power is going to be equal to 16. Okay, that's what it means. Or we're looking for the number that multiply times itself 4 times. The number that multiply times itself 4 times is 16. That's another way of seeing it. Okay, let me give you some more. If you think you got it, you can start working. Actually, no, let me, even though you saw this before, you might need it. So this is an additional aspect to it. It just means solve this first and then raise that to the 2nd power. So let's pretend that we don't have that. We're going to move it along later. And so one number multiplied times itself 3 times gives me 27. Some of you already know that is 3. But if you're not sure, 3 times 9 is 27. 3 times 3 is 9. How many in the cage? How many in each group? You need 3 in each group and only send the captain, which is 3. But then you move, oops, I went a little too far. Then you move along this because this is the answer. But now you have to carry on the exponent. And so 3 to the 2nd power is 3 times 3 is 9. So that will be the answer. Okay. Next one. 16 to the 2nd power. Notice how in here the exponent is outside. In here you have it inside. It doesn't matter. You can still, oh, and I forgot the 4 in there. You can still do this part first and then carry the exponent second. Or if you want, you can work with this first and then take the root of index 4. However, oh, I'm so sorry. However, that's going to be a lot more work because this is going to be a huge number. Okay, so I prefer to work with this first. And so it's going to be 4 times 4, 2 times 2, 2 times 2. It says to put 4 in the cage and send the captain. So it's going to be 2, but then you carry this exponent over here. And 2 to the 2nd power means 2 times 2, which is 4. And so that's going to be my answer. Apologies for the last couple of shaking, etc. But that's it, and have fun.